Quantum computing, the game changer since fire, revolutionizing tech beyond. Imagine a technology so revolutionary it could rewrite the rules of human progress, as fundamentally as the discovery of fire did millennia ago. This is the audacious claim made by Bank of America regarding quantum computing, a technology poised to redefine the limits of computation and, by extension, our world. In a recent report to investors, analysts at Bank of America boldly stated, "This could be the biggest revolution for humanity since discovering fire." They envision a future where quantum computing can process vast amounts of data and solve complex problems at speeds unimaginable with current technology. The implications are staggering, from accelerating scientific discoveries to enhancing artificial intelligence, AI capabilities. But here's where it gets controversial. While the technology is still in its infancy and not yet commercially viable, the potential economic value it could unlock is immense. Bank of America has not yet initiated coverage on any quantum computing stocks, indicating that while the future looks bright, the path to realizing this potential is still uncertain. At its core, quantum computing leverages the principles of quantum mechanics to perform calculations at an exponential rate compared to classical computers. Traditional computers use bits, represented as zeros and ones, to process information. Quantum computers, on the other hand, use quantum bits, or qubits, which can exist in multiple states simultaneously. This allows them to handle complex computations far more efficiently, potentially solving problems in minutes that would take classical computers thousands of years. While the tech industry is currently abuzz with discussions about AI dominance, Bank of America argues that quantum computing should be the ultimate focus. According to the bank, quantum computing will not only enhance AI but could push it to new heights, even reaching the realm of artificial superintelligence. Gen AI can help speed up the development and testing time of quantum systems, which could take AI model training to the level of artificial superintelligence, the report states. And this is the part most people miss. Quantum computing has the potential to reset the global technological balance, influencing everything from economic power to military superiority. As Haim Israel, a Bank of America analyst, told CNBC, quantum computing is the first technology that will reset everything, that will put everybody back at square one. Any government that is the leader in that has a huge advantage and everything can change. The power of quantum computing was demonstrated last December, when Google announced that its quantum computer solved a problem in just 5 minutes that would take a classical supercomputer approximately 10 septillion years, a time span longer than the age of the universe. The real-world applications are vast, ranging from faster drug discovery to more accurate climate modeling and optimized logistics. One of the main reasons Bank of America is so enthusiastic about quantum computing is its unparalleled ability to process massive amounts of data. Israel points out that over 400 quintillion bytes of data are generated daily, equivalent to 400 million terabytes. For context, most smartphones can store only up to 1 terabyte. We live in a world of data. Traditional computing does not give us enough abilities to crunch data and very complex problems that humanity is facing in a real way, he explained. However, despite the excitement, quantum computing is not without its challenges. To date, the technology has yet to solve any practical real-world problem faster than a traditional computer due to issues like noise, which introduces computational errors. Moreover, quantum technology is still several years away from widespread adoption. Nvidia CEO Jensen Huang predicts that it could be more than a decade before we see truly useful quantum computers. If you kind of said 15 years for very useful quantum computers, that'd probably be on the early side. If you said 30 is probably on the late side. But if you picked 20, I think a whole bunch of us would believe it, he told Wall Street analysts. Other tech giants share similar timelines. Companies like Google, which are developing prototype quantum computers, don't expect to deliver a practical quantum computer for at least 5 to 10 years. IBM scientists, meanwhile, aim to produce a universal quantum computer suitable for commercial applications within the next decade. So what does this mean for the future? The potential of quantum computing is undeniably exciting, but the road ahead is long and fraught with challenges. What do you think? Is quantum computing the next big leap in human progress? Or is it just another hype cycle? Share your thoughts in the comments below. Quantum computing breakthrough, large-scale deployment now possible. Imagine a world where computers solve problems once deemed impossible, revolutionizing industries from healthcare to finance. This is no longer science fiction. It's the promise of quantum computing, and a groundbreaking discovery has just brought us closer than ever. For decades, the dream of harnessing quantum power for everyday challenges has tantalized scientists, yet technical hurdles kept it just out of reach. But here's where it gets exciting. A recent breakthrough in refining magic states within logical qubits has shattered those barriers, paving the way for large-scale quantum deployment. So, what makes quantum computing so special? At its core, it's all about how information is processed. Classical computers use bits, simple zeros or ones, while quantum computers use qubits, which can exist in multiple states simultaneously, thanks to a phenomenon called superposition. This isn't just a small upgrade, it's a paradigm shift. And problems that would take classical computers millennia to solve could be cracked in seconds with quantum systems. Think unbreakable encryption, precise drug discovery, or optimizing global supply chains. The possibilities are staggering. But here's where it gets controversial. Quantum computers are notoriously fragile. Even the slightest vibration or electromagnetic interference can disrupt qubits, leading to errors. While classical computers boast error rates of 1 per million operations, quantum systems struggle with 1 per thousand. Is this fragility a deal breaker, or can we engineer our way around it? The answer lies in error correction and fault tolerance, where logical qubits, groups of physical qubits working together, detect and fix mistakes. Yet this solution isn't without its challenges. Logical qubits demand more resources and complexity, and their success hinges on high-quality magic states, which until recently were elusive. Magic states are the unsung heroes of quantum computing, enabling advanced operations that push the boundaries of what's possible. However, impure magic states introduce errors, making them impractical for large-scale use. And this is the part most people miss: distilling these states. Purifying low-quality magic states into fewer high-quality ones was long considered theoretical. That is, until researchers at Qubit achieved the impossible, distilling magic states within logical qubits for the first time. By transforming 5 imperfect states into one pristine one, they've unlocked a new era of computational reliability and scalability. This breakthrough isn't just a scientific milestone. It's a game-changer for industries. Finance, logistics, pharmaceuticals, and cybersecurity are poised to reap the rewards, with quantum systems tackling complex tasks at unprecedented speeds. But the impact doesn't stop there. Chemical modeling, energy grid optimization, and even secure communications stand to benefit. Yet questions remain. Can we manufacture quantum processors affordably? How do we ensure seamless integration with classical systems? And what does this mean for the average person? While large-scale deployment is closer than ever, challenges persist. Manufacturing, error correction, and user-friendly programming tools require global collaboration. But the momentum is undeniable. With each innovation, the gap between lab experiments and real-world applications shrinks. So here's the big question. Are we ready for a quantum-powered future? And what role will you play in shaping it? Let's discuss. Share your thoughts in the comments below. Top 5 Fastest Quantum Computers in 2025. Qubit Power Future Tech. The top 5 fastest quantum computers in 2025. Quantum computing is on the brink of a revolution. By 2025, the field has made remarkable strides, with various systems pushing the boundaries of computational capabilities through increased qubit counts, enhanced error correction, and practical applications. This article presents an overview of the 5 fastest quantum computers, evaluated based on their qubit counts, quantum volume, error correction abilities, and real-world applications. Each entry provides insights into the brand, specifications, distinctive features, and significant uses, highlighting their impact on sectors such as cryptography, finance, and material science. Chapter 25, IBM Condor. Also read about building Starling, IBM's fault-tolerant quantum computer coming in 2029. AM. Dig.in/features, general/building Starling, general/building Starling, general/building Starling, general/building Starling, general/building Starling, general/building Starling, general/building Starling. Introduction. We'll launch into the abundance of 10,000 quantum qubits. Although its quantum volume isn't explicitly mentioned, it is expected to be outstanding. Due to IBM, housed within IBM's quantum system 2, Condor operates in the GoldenEye cryogenic refrigerator, the largest of its kind, which cools over 1 cubic meter to millikelvin temperatures to ensure qubit stability. Accessible through IBM's quantum cloud platform, it enables researchers and businesses worldwide to conduct experiments using Qiskit, an open-source quantum software framework. As a precursor to the upcoming Kookaburra processor, which will feature 1,386 qubits, Condor employs a multi-chip configuration that lays the groundwork for quantum communication links. This system excels in cryptography, tackling intricate problems like factoring large integers, which could have significant implications for encryption standards. Additionally, it aids material science by simulating atomic-level properties for renewable energy and electronics, supports financial institutions like Waksha Bank in portfolio optimization, and enhances drug discovery by refining molecular modeling for pharmaceuticals. Atom Computing's Quantum Computer. Atom Computing's quantum computer features a 1,225-site atomic array with 1,180 populated neutral atom qubits, marking a significant advancement in scalable quantum technology. While its quantum volume is not publicly disclosed, the impressive coherence times of neutral atom qubits indicate strong computational capabilities. The system benefits from low error rates due to the inherent stability of neutral atoms, which are less susceptible to environmental noise, allowing for extended computation periods. Unlike superconducting systems that require extreme cryogenic cooling, this computer utilizes trapped neutral atoms, which may allow for room temperature operation in the future, potentially lowering costs and enhancing scalability. Atom Computing's innovative approach positions it as a practical option for scaling to larger qubit counts. Primarily, this system is utilized for optimization tasks, addressing complex combinatorial problems in logistics and supply chain management. It also facilitates quantum research, enabling institutions to investigate new algorithms and error correction methods. Furthermore, it shows promise for financial applications, such as Monte Carlo simulations for risk assessment, akin to those explored by J.P. Morgan Chase using trapped ion systems. Google Willow. Google Quantum AI's Willow quantum computer, equipped with 105 superconducting qubits, is notable for its pioneering error correction and computational performance. Although its qubit count is lower than some rivals, Willow achieves below-threshold error correction, which exponentially reduces error rates as qubit grids expand from 3 by 3 to 7 by 7, representing a significant advancement toward fault-tolerant quantum computing. With coherence times nearing 100 microseconds, a 5-fold enhancement over previous Google chips, it supports high circuit depths for intricate quantum operations. Integrated with Google's Cirq, an open-source quantum programming platform, Willow aids researchers globally in algorithm development. Its capabilities are particularly impressive in cryptography, where it successfully factored a 2048-bit RSA key in just 7.5 hours, raising important questions about blockchain security and cybersecurity. Willow also accelerates AI and machine learning by efficiently processing large datasets, supports energy research through simulations for fusion and battery design, and enhances healthcare by enabling quicker molecular simulations for drug discovery. Also read, Google Willow quantum chip explained, faster than a supercomputer, https://www.digit.in/faster than a supercomputer. Chapter Quera's fault-tolerant quantum computer. Quera Computing's quantum computer, developed from research at Harvard and MIT, features 256 physical qubits and 10 logical qubits in its 2024 model, with plans to scale up to 3,000 physical and 30 logical qubits by 2025. Its low error rate of 0.5% with 48 logical qubits surpasses competitors like IBM's Heron, which has a 2.9% error rate with 3 logical qubits, establishing it as a leader in fault-tolerant computing. Utilizing neutral atom qubits, Quera harnesses quantum entanglement to achieve high computational stability and flexibility for a variety of algorithms. The company's roadmap includes a 10,000 qubit machine with 100 logical qubits by 2026, which could potentially outpace supercomputers for specific tasks. This system is applied in logistics to optimize routing and supply chain efficiency, in finance for quantum Monte Carlo simulations to improve risk modeling and portfolio optimization, and in materials science to simulate new materials for environmental applications like carbon capture. D-Wave Advantage. D-Wave Systems Advantage Quantum Computer, featuring over 5,000 superconducting flux qubits, is tailored for quantum annealing, excelling in optimization tasks rather than general-purpose computing. Its 15-way qubit connectivity enhances performance for complex combinatorial problems, although its annealing paradigm limits error correction compared to gate-based systems. Available through D-Wave's Leap Quantum Launchpad, which offers a 3-month free trial for eligible users, Advantage is accessible to businesses and researchers alike. It has been utilized by Toyota to optimize manufacturing logistics, resulting in a 32% reduction in supply chain disruptions, and by Goldman Sachs for portfolio optimization, enhancing asset allocation efficiency by 27%. The system also supports supply chain applications, optimizing scheduling and delivery routing to minimize costs in sectors like transportation. In 2025, the landscape of quantum computing is characterized by rapid advancements in qubit scalability, error correction, and practical applications. IBM's Condor leads with its extensive qubit count and cloud accessibility, while Atom Computing's neutral atom system presents significant scalability potential. Google's Willow stands out for its error correction capabilities. Quera pushes the boundaries of fault-tolerant computing, and D-Wave excels in optimization tasks. These systems are revolutionizing industries, from cryptography and finance to logistics, healthcare, and material science, signaling the dawn of a new era in computational innovation. Also read Quantum Computing's Next Leap: How Distributed Systems Are Breaking Scalability Barriers. www.digit.in feature/science/quantum computing's next leap: How distributed systems are breaking scalability barriers. Vyom Ramani is a technology journalist with a passion for tech, games, and all things that beep. When not waiting for a delayed metro or rebooting his brain, you can find him solving Rubik's cubes or on the hunt for the next great snack.